Thank you. This is the last session of the last day of KubeCon North America. It's not easy here. We are very grateful and appreciate that you are not hurried to leave and come here to attend this topic. Hope that you can enjoy it and get something useful.
And we will try to finish it as soon as possible, so you guys can still have some time to other sessions.
First of all, let us to introduce us. Dixu is a very smart and diligent software engineer and financial. He works on PaaS solution based on Kubernetes, and he is an open source contributor. Now he is the top 50 contributor in the core Kubernetes repository. My name is Xiaoyu Zhang. It's hard to pronounce it for non-Chinese speaker, so forget it.
You just call him Dim.
I work in Alibaba Cloud, which is a great and aggressive cloud provider, just like AWS and Azure. Okay, here you can remember it. Maybe you will use it. Now I'm in charge of Kubernetes release and the reliability and some new features research and enhancement in Alibaba Cloud. I'm also a Kubernetes community member, which proves that I did some contribution to the community. So let's start our topic.
And here is today the agenda of our session. Firstly, I will go through what Sidecar is. And secondly, I will show some typical usage in Alibaba and financial. Then we will try to show you that how we tackle these challenges on financial and Alibaba Cloud. Last but not least, there are still some remaining issues to be addressed. So we need all your help to bootstrap the Sidecars to next level. Actually, Sidecar is not a new thing, it's kind of design pattern. So if you are familiar with Docker Swarm, you may remember that Docker Ambassador is kind of sidecars. So sidecars are usually used to do accessory things that are coupled and from the main service containers. Look at the below graph. Here is the service. There are two containers that are running on two hosts. One is the consumer, the other is the service provider. So they're coupled, and the network is hard linked. So it's very not easy to switch to another Redis instance if you change if the original server is down. So if you add the Redis ambassador here, so it will become very easier to switch into another instance. And by adding an ambassador, this also allows you to transparently move the Redis server to another Docker host from the consumer. So actually, Sidecars can do a lot of things, not only just serving as a ambassador or proxy server. You can use Sidecars to forward your logs to another host. This is exactly what Fluentd is doing right now. So also, Istio and LinkedIn use Sidecars to help simplify the traffic management and service security and monitoring, etc. Also, you can use Sidecars to do some other accessory things like copying files, downloading files from the internet, or other stuff. Actually, this Sidecar pattern enables applications to be composed of heterogeneous components and technologies by reducing coupling. This pattern is best used when there are clear differences between the primary container and the other secondary tasks that need to be done for it. Also, the demands for using Sidecar containers in production environments are rapidly increasing. This is a major challenge that we met in Alibaba and financial. Although Sidecar container has not formally identified, so there are more enhancement issues and discussions should be talked about. I will show you some use cases. Those are some typical use cases, not only on financial but all over the world. So On the right is a normal pod spec. We can see there are 3 containers here. I'll just omit some unuseful information here, so we just focus on the main part. The 3 containers are proxy, service, and MySQL client. The MySQL client here is mainly used to connect to a remote MySQL cluster. So, and also it exposes local service to the service container. So the service container will just use the local service on the MySQL cluster. And the proxy container here is mainly used to set up the network connectivity so that the MySQL client can connect correctly to the remote MySQL cluster. So we can see there is a hierarchy of the order of the containers. The proxy container should be started first, and then the other 2 normal containers. Also, this is the second use case, Sidecar management. Actually, currently, the normal containers and Sidecar containers are coupled closely, so they are sharing the same lifecycle of the pod. So it is not convenient to manage Sidecar containers separately, such as upgrading Sidecar container images. So have you ever used about service mesh, Istio, or Linkd? Oh yeah, quite a few. So actually, suppose that we have already running pods that have injected the proxy containers. So if you want to upgrade from the older image to a newer one, so what do we do? So the official guide just suggests us just to re-inject the Sidecar containers to the pod. But what if we have hundreds of deployments, thousands of deployments? So you really want to do it manually? Of course not. And also there is another issue. So how can we upgrade our deployments step by step? That means we may just want to upgrade partial sidecars of the deployment. How can we do it?
So let's throw this question problem to the community. Now we will seek some sidecars process on community. Sidecar, the key API implement is merged now. Thanks for the Joseph Aaron for his such great lesson. He defined a field in the pod spectrum, lifecycle, which is used for identify which is standard container and which is sidecar container. And the pull request is under another pull request is ongoing. This is modified Kubernetes and is under review now. After its merger, we could use the lifecycle type to mark which is sidecar container. But as we know, it's not enough to only define which is sidecar. There are lots of logical business to discuss and develop. The first thing I want to list is the setup sequence of sidecars and standard container. So Shimi and I wanted to do it further, so we send another peer to add more options for lifecycle type. Those are per sidecar and per sidecar. Those are new options. Could help to mark a startup sequence of sidecar and send the container. Here, a really use case in Alibaba could show why those options are permanent and really resolve some big problem. Here is a use case example. Sidecars containers would be started up or shut down before or after normal container. And the order does very matter. In our producer environment, as to some application, tier container, tier is another open source project released by Alibaba Cloud. and which is a distributed key value cache system. The container of tier should be started before a commercial container and do some preparation for the standard container. This is a very good example to prove the startup sequence is very important. Of course, we also have some other use cases of some post-Sidecar. Consider that decoupling, we separate application into the two parts. Normal container, which focus on logical business. Post-Sidecar container, which is in charge of configuration data. Usually, those two containers will share one volume, and the post-Sidecar will update data and replace some default or out data of the normal container. So the sequence is very important for us. Though we have not met more complex cases which demand a DAG for container startup sequence. So, but it's possible to happen when more and more complicated applications run on Kubernetes. We will send more issues and peer to discuss and enhance this feature gradually and discreetly. So, before the Sidecar enhancement and KEP release in upstream Kubernetes community, we found some solutions for Sidecar. This is the open source project, open course. What's the open course? Open course is a set of controllers which extend and complement of Kubernetes core controllers on workload manager. Currently, it has 3 ready workloads: self-set, sidecar set, and broadcast job. It will do help user on application level. So everybody could download this image and have a try on the tutorials. So,
and thanks, Lakeland, for having a try on open course, and congratulations to Lakeland for winning the Contributor Award of 2019. So actually, sidecars are less controlled and treated equally with normal containers. Actually, they're not. They have different life cycles. So this is what the upstream community lacks, and this is what Sidecar set does. With more diverse scenario coming, current sidecars cannot meet our requirements anymore. This is how we solve it. By using sidecar set, we need a fine-grained controlling. And this is a common spec of sidecar set. You can say we have defined a new type named the sidecar container, which is exactly the same with the core container in Kubernetes APIs. So you can use it. You just copy the original definition from the core containers. And we have already defined the update strategy on how to upgrade our sidecar containers. You can also set an available number of sidecar containers. This is a sidecar spec. So we use selectors to select all the matching pods that we want to upgrade, and insert all the sidecar container images and volumes. So it will do in-place sidecar container image upgrade, mounting sidecar volumes, etc., etc. Basically, sidecar set decouples the sidecar container lifecycle management from the main container.
Here's the roadmap of the cross project. You can pick up those sidecars information. According to this description, some enhancement has been done, such as parallel upgrade sidecar set ports and support sidecar volumes. And some features like other partition support for sidecar is in process, and not longer selector upgrade sidecar is on scaling. So we can do more detail. The user can get more details about the features and the roadmap from the cross official website and discuss and send some issues to ask some more features.
So actually, we have opened an issue for checking our latest status. So if you guys are quite interested on how the upstream, the Prometheus upstream, does on Sidecars, you can just subscribe our issue here, and all your comments you can leave all your comments to our issue. Any contributions are also welcome. What's next? There are still some remaining challenges that really should be addressed. So it is worth to pay attention to. The first is resource allocations. So the question is, should the resource consumption of sidecars should be calculated into the whole pod? You can just see the right graph. We have a regional pod, which we will have two containers. One is the standard container or normal containers. The other is the sidecar containers. Actually, the sidecar containers are consumed very little, very few CPU and memories, but the total resource of the pod is calculated, right? But actually, in most cases, sidecar containers only consume very few resources comparing to other containers. So should we really want to calculate the sidecar container resources into the pod level? So actually, we have different ideas. And the answer quite varies. You can think, well, it's a normal. The sidecar container should be calculated. But for us, sidecar containers only do accessory jobs. They only need to acquire very few resources. So we just solve in another way, which is a non-native way. So we don't want to put the answer here. So if you guys want to have more discussions, feel free to talk to us later.
Exactly.
Yeah. And another question is, it is very hard to define the exact resource consumptions. So you can allocate a large number of resources, or you can just a few. So it's your own options to define how you want to do with sidecar containers. Another challenge is how to maintain the failure tolerance. Actually, we know that sidecar containers only do accessory jobs, right? So this accessory jobs should not be affected with normal containers. So when we upgrading the sidecar container images, should we mark the pod down or failure? Actually, the answer depends. So this is another challenge that should be considered and should be discussed very in deep.
So, have you been to visit the Midway aircraft? At the first day, we come to San Diego, and we visit the USS Midway aircraft. And we are amazed that there are too many buttons and switches. You cannot imagine how difficult to handle this big ship. At least, Kubernetes is not easy to handle, because with the help of the community and more contribution from all the people, you can handle Kubernetes to cruise with easily. The second picture is Dishu, followed by me. And he was pretending to operate the helm of the Midway aircraft. Cheer for his courage. So if you have any questions on Kubernetes, Alibaba Cloud, and something others, open cross pod level resource quota, please feel free to keep in touch with us. Here is the way to contact us. You can ping us on Slack, GitHub by using our handle. Dishes and my are shown here. Listen. Thank you for coming.
And finally, we made our promise. And we try to finish it as soon as possible, so you guys can still have time to our sessions. And we still have a lot of time to discuss the Sidecar containers. So if you guys have any questions, feel free to raise your hands.
Questions?
Yeah. I just want to make sure I was understanding it correctly. So with the sidecar set, would that be its own independent deployment object outside of your primary application, and then it's just injected to the pod alongside your app?
Yeah, actually, you just need to create your normal pod, and the sidecar will be injected in the API server level. There will be a mutation webhook controller that will try to inject the sidecar container into your pod. So you don't need to worry about how to inject the containers. You just need to deploy your normal pod.
So would you be able to just update that singular object, and then it would just inject in the new version of the sidecar? So in your example, if Istio had a version update, you would just be able to update that singular sidecar set?
Yeah, of course. Sidecar set will try to inject the same name, the sidecar container with the same name. And you have already defined the latest version of the sidecar containers. So we just try to inject the newest sidecar container into your original pod. Actually, if you have deployed the sidecar set, you don't need to deploy another webhook container, mutation webhook. And the sidecar set will do everything for you. You just need to deploy the spec into the API server. It's done. Simple.
Super easy.
Yeah.
More questions? No one want to leave?
Hey, thank you for the talk. A challenge we face frequently is we have tens of thousands of pods, and all of them are running our service mesh sidecar.
Yeah.
So now if you want to update the image, we need to bounce all of our pods, basically to recreate all of our pods across all of our clusters. Does Sidecar set solve that problem?
Yeah, of course. Normally, you try to, if you want to update the Sidecar container image, you need to redeploy the pod. Or you need to delete the pod, and the deployment controller will try to create a new pod for you, right?
Right.
Yeah, so this is it's not very handy. So all you want to do is a fine-grained way. That is what Sidecar set does. Sidecar set will try to can help you partial update the sidecars. Also, it will try to inject all the containers. You can just manage all the sidecars into another separate workload. This is different from the normal pod lifecycle.
As it said, the sidecar should be uniform with the standard container. So it has its own life cycle, right?
Yeah. They have two different container life cycles. So if you guys have got any questions, feel free to talk to me. I will stay here for several minutes or an hour.
Anytime.
Okay. Have fun. That was KubeCon.
Thank you for coming.